In the last video, we took a brief look at the naive Bayes algorithm, and we kept it pretty simple. We just used one variable to predict the outcome of another variable, but this time we're going to make it a bit more interesting. We're going to have multiple variables used to predict a couple classes that maybe isn't so obvious. And so let's look at the word equation of this algorithm. We could break it up into these big moving parts. We have the posterior, which is kind of like our estimate. And our estimate we write as the probability of our class, of our selected class, which is CK. The probability of our selected class given that our features have occurred. So our features, before we were speaking in terms of variables, but really these are features since this is a classifying algorithm that we're working with. So our different features, and we'll define that in our example. And then we have the prior. What's this? Well, this is the probability of our selected class occurring. The likelihood is the probability of our features occurring given that our selected class has occurred. And the evidence is the probability that our features have occurred. And this evidence, sometimes you see this as Z, written as Z, and it's basically a normalizing function. It's the way that we can figure out how much do we trust this top product. How much can we lean into the evidence given in this numerator? So those are the big moving parts. Let's look at a real example though, because I think it's helpful to actually look at some tangible numbers. So we have a story here. We have you and I are in a joint venture, and we've actually opened up a competitive video sharing platform similar to YouTube, and we're trying to figure out what is it that causes people to want to sign up. And we have, look at us, we have 9 examples where people have signed up, and we've gathered a bit of metadata. So now we have 9 samples where we can see people have sometimes joined, and they have sometimes stayed for longer than 30 seconds, and they've sometimes watched a video, our introduction video, and sometimes they haven't. But let's turn this into a business question. We want to find it. We want to be able to predict what the likelihood is. What the likelihood is if somebody has stayed longer than 30 seconds on the site. And we'll say that this is true. This is our set of features. We're interested in seeing if when they have stayed longer than 30 seconds on the site and when they have, let's say, not watched the video, we want to see how likely it is that they will in fact join. So our selected class that we're testing for is join equals true. So that's what we're testing for. Now we can go to our main equation here and start filling in these different terms. So if our selected features are looking at cases where people have actually stayed longer than 30 seconds and they have not watched our video, and our selected class is cases where people have in fact joined, now we want to look at the probability that people have actually joined. Well, we have 9 observations, and out of those 9 observations, how many people have actually joined? 1, 2, 3, 4, 5. So this probability, we can say there is 5 cases out of the total 9 observations where they've joined. I'm just going to write this in the corner here. The probability of our selected class occurring is 5 over 9. Or if we round to 2 decimal places, we'll just say 0.56. Okay, so we've looked at all observations. We're not constraining it to any case yet, but in this next term we are. We're asked to find in this next term the probability of our features occurring. Our features greater than 30 seconds and people who have not watched the video. What is the probability of our features occurring given that our selected class has also occurred? So we can't look at all observations. We can only look at cases where the selected classes occurred, and we've marked those here on the side. There's only 5. There's not 9. There's only 5 cases. So what's the probability that our selected features will occur given that our selected classes occurred? Well, we can break this into 2 components. We have the first column here, and we can count it up. We can say, did they join? Yes, they did. We count this as 1 because they stayed longer than 30 seconds. They did not stay longer than 30 seconds here. We'll disregard that. They stayed longer than 30 seconds and they joined. Well, so that's 2, 3, and 4 cases total. So there are 4 cases total where they stayed longer than 30 seconds out of the 5, not 9 total observations, but 5 constrained cases where our selected class is true. So we finished our first column. Now let's look at the second column in video. And we're still constrained to the same cases. We're only looking at those observations when people in fact joined. But this time we're looking at when they did not watch the video. And I only count 1 example where they did not watch the video. So we're going to write 1 out of the 5 cases where the selected class was true. So we can write that down in the corner as the probability of our features occurring given our selected class has occurred. And in decimal form, we'll write this as 0.16. Okay, last part. So now we just have to calculate our evidence. So what is the probability of our features occurring? And that, let's stop for a second. And we just need to notice that there is no condition in this last term. There is no condition like up here. We see up here, we're asked to find the probability of the features occurring given that the selected classes occurred. But down here, there is no condition asking us to only constrain the probability to when the selected classes occurred. And that means we have to use all 9 observations. We're not going to use these 5 observations. We're going to use all 9 observations. And that's really important. It's easy to get confused in probabilities if you don't know which range of observations you have to check your probabilities in. So we're looking at the probability. Again, we're going to break it up into 2 parts, into the 2 columns. We're looking at the probability of people staying longer than 30 seconds out of all observations. So we count that 1, 2, 3, 4, 5. 5 out of our 9 total observations, people have stayed longer than 30 seconds. And now we're going to multiply that by the number of times where they did not watch the video, because that's what we're looking for. We're not looking for cases where they have watched the video. We're interested in cases where they have not watched the video. So we can count that as 4 cases. So we'll write that as 4 out of our total observations. We're very close now. We can write this down as the probability of our features occurring in decimal form as 0.25. All right, so we're very close. Now we can see that this is equal to 0.36. We also need to figure out what the probability is of people not joining when these features are true. And if we do that, I've already done that, you can see that it is 0.33. Now, 0.33 is not very far off from 0.36. And what's great about this algorithm is it uses probabilities to figure out which is most probable. So we can just say, well, which one is more probable than the other, and then choose that as our answer. And that is called argmax. Let's actually look at the more general formula now, so you can see instead of looking at the probabilistic model, which is what we've been working on, let's look at the actual classifier and how that's written. So that's written like this. We can say that the predicted class Y is equal to argmax. In other words, just choosing the highest value out of a set of outputs where k is in some set of numbers between the first class all the way up to the maximum class. And so we have to generate that set of numbers. And so to do that, we're going to say the probability of our selected class occurring for each, and we will multiply by using capital Pi. We're going to say for each class, a range of our classes, up to n classes starting at 1. And in our case, we have 2. So we're going to write n is equal to 2 up here just so we can see that. So for the range of, not classes, for the range of features available, we're going to multiply our cases where our features exist constrained to when our selected class exists. And so when you put this all together, you're going to see that this works out to the exact calculations that we worked on before. This capital Pi is just saying multiply the probability of our, this is our prior here, multiply the probability of our selected class occurring by each column where, remember how we split up the different columns, each column or each feature, the number of features where the selected class is true. And so hopefully this notation makes a little bit of sense. This is generally how people write down the classifier, and that is how the naive Bayes classifier works.